Hello everyone, I am Sujata Morir. Welcome you all in the video lecture on the topic Differential Calculus, Taylor's and Maclaurin series. Taylor series. If y is the function of x, then f of x plus h equal to f of x plus h f dash of x plus h square by 2 factorial f double dash of x plus so on. Here, this is the expansion in power of h. Maclaurin series here f of x equal to f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 and so on. That means here we have to find out the values of f of 0, f dash of 0, f double dash of 0 and so on and substitute in the formula, and then we get the answer of the or expansion of the function in power of x. Therefore, Maclaurin series is the expansion in power of x. X. Third series is expansion in power of x minus a. That means here we have to find out f of a, then f dash of a, f double dash of a, and so on. Here x minus of a term, here x minus of a whole square and upon 2 factorial and so on. Now we discuss the problem on the Taylor's, Maclaurin and expansion in power of x minus a series. Here expand e to the power x in power of x. This is the application of Taylor series, Maclaurin series, and expansion in power of x minus a. Actually, Maclaurin series and expansion in power of x minus a, these are the deduction from Taylor series. Now here we consider f of x equal to e to the power x. Now expansion in power of x, therefore we use here Maclaurin series and find out minimum three terms of this series. Now f of 0, we substitute x equal to 0 here, therefore e to the power 0 is 1. Then f dash of x, its value e to the power x, again its value 1. F double dash of x, e to the power x, its value 1. We using Maclaurin series, we write down the series f of x equal to f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 and so on. This is equation 1. Now therefore we substitute all these values in equation 1. Here f of 0 is 1, then f dash of 0 1, f double dash of 0, and here f of x value is e to the power x. Therefore on simplifying this we get the e to the power x series 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. This is the expansion of e to the power x. This is the application of Taylor series. Now, secondly, we consider expansion of f of x equal to sin x. Now, here f of x equal to sin x in terms of x, therefore again we apply here Maclaurin series. Find out minimum three terms, therefore f of x equal to sin x, f of 0 is 0. Then f dash of x, f double dash of x and so on. We find out next derivative. Here the value of sine, whenever there is sine term, its value is 0. Therefore here 0 0 0. Therefore we find out minimum three terms here, f dash of 0, then f triple dash of 0 and f phi of 0. Now we substitute in the Maclaurin series. This is the series gives equation number 1 here. Substitute the values here. This f of 0 is 0. Then f dash of 0 is 1. Therefore x here. F double dash of 0 its value 0. F triple dash value its 1. X cube by 3 factorial into 1 here. And next value differentiation is 0. And after that its value 1, and then we write down the Taylor series as this way. Here we can solve this by applying nth order successive differentiation formulae. Also we can find out the values f dash of 0, f double dash of 0 by using the nth derivative formulae. Substitute n equal to 1, n equal to 2 and so on. Now expand cos x plus h in power of h. Therefore we apply here Taylor series. F of x plus h equal to f of x plus h f dash of x plus h square by 2 factorial f double dash of x and so on. For this we consider f of x value. Now here f of x plus h, its value equal to cos x plus h. From this we easily write down the value of f of x. F of x equal to cos x. Therefore, we consider here f of x equal to cos x, then find out f dash of x, f double dash of x, f triple dash of x, and substitute in the formula number 1, equation number 1, then we get the required expansion of cos x plus h. Now next example, expand log x in power of x minus of a. Now here we applying the expansion in power of x minus a series. Use here equation 1 and value of a here equal to 1. Therefore, we find out f of x value, f dash, f double dash, f triple dash, and all these values at the point a, x equal to 1. That means f of 1, f dash of 1, f double dash of 1, and so on. Then we get the series log of x equal to here f of a, its value 0. Then x minus of 1 into f dash of a, its value 1. In this way, we substitute the value, we get the required solution. Now, if you observe this series is in terms of x minus of 1. That means this is the application of Taylor's Maclaurin series. Here we can expand this log x in terms of x minus of 1, any value x minus of a term by using Taylor series, by using Maclaurin series, expansion in power of x minus a. That means one value, one function we can express by different ways. Now, this is another application we can find out the values of sine, cos, tan values by using Taylor's expansion. Now here, use Taylor expansion to evaluate sine 60 degree 30 minutes given sine 60 degree value and 1 degree in terms of radii. Now here by using Taylor series f of x plus h equal to f of x plus h f dash of x plus h square by 2 factorial f double dash of x and so on. Now, here we have to write down the value of f of x. Now, sine of 60 degree 30 minutes, its value is here we consider this 60 as x and 30 as h. But here this is the value of sine x plus h, which is equal to f of x plus h. Now we are interested in finding the value of f of x. Now f of x equal to sine x. Therefore, we consider here f of x equal to sin x, then we find out first derivative, second derivative, third derivative, and then we substitute all these values in equation 1. Therefore, sin x plus h equal to sin x plus h cos x plus h square by 2 factorial minus sin x and so on. Now we substitute the value. Here sine of 60 degree 30 minutes. Now x equal to 60 degree and h equal to 30 minutes. Therefore, in terms of radian here 1 radian divided by 2. This that means here a half degree 0.01745 divided by 2 we get this value. We substitute these values and simplify the terms, then we get the required result. Actually, here we break up this series. We cannot consider the higher order terms because this value is very small. H is always very small value, and it's we consider up to cube. It's 4 to the power 4. It's very small value. Therefore, neglecting all higher order terms, and its answer is 0.87036. In this way, we can find out any values, that means tan 46, cosec 61 in the, by applying same method. This is the again application of Taylor series. Now, in this way, we can find out the values of under root of 10. Now, under root of 10, this is the value we can return as under root 9 plus 1. Therefore, here we consider the value of f of x equal to root x. Now, then x equal to 9, h equal to 1, and apply here Taylor series theorem or Taylor series formula and find out the required result. Similarly, here find f of 11 by 10 if f of x equal to algebraic values. Here f of 11 by 10 can be written as f of 1 plus 1 by 10. That means x equal to 1, h equal to 1 by 10, and apply here Taylor series and find out the required result. In this way, there are so many applications of this, and we can find out different values of root 10, root 101, and then f of these values, expansion in power of x minus of a values may be 1, 2, 3, and plus minus 1, 2, 3, and so on. Then log of sec of 31. That means different values we can find out in terms of series, and by using these Taylor series, Maclaurin series, and expansion in power of x minus a. Thank you.